GCSE Physics Boosters, Wave Basics. This is the first video for the waves topic, just covering some pretty basic ideas to start with. Now, there's lots of different types of wave. Now, lots of waves need a medium to travel through. They have to travel through something, a solid, a liquid, or a gas. And that's called a medium, the thing that it travels through. Now, electromagnetic waves, they don't need a medium. They can travel through a vacuum. Anyway, lots of types of waves. What are the pictures here? We've got sound, ripples on a water, slinky. You can make various types of waves with slinky, earthquake waves, waves traveling down a string, such as on something like a guitar, ultrasound, lots more, lots of different types of wave. A wave is basically how energy can travel through a medium to get from one place to another. Now, this is a transverse wave. Two types of wave, we can categorize them into transverse and longitudinal. Now, in a transverse wave, the waves travel in a certain direction. Now, the particles in the medium, notice that they are moving, they are oscillating perpendicular at right angles to the direction that the wave is traveling in. Okay, so in a transverse wave, the particles in the medium oscillate perpendicular, or you can say at right angles to the direction that the wave is traveling in, and that is a transverse wave, such as a water wave. Now, this is a longitudinal wave. Now, again, the waves are traveling from left to right, and the particles are oscillating parallel to the direction the wave is traveling in. The particles are the air molecules, because this is sound traveling through air. Remember, transverse, perpendicular, longitudinal, parallel. Okay, and those are the two types of wave, transverse and longitudinal. Longitudinal waves are made up of compressions and rarefactions. Now, what does that mean? That means that in some places, the air molecules are kind of squished together. They are compressed together. And these, I'm labeling now, these are compressions, okay, where the particles in the medium are compressed together, squished together. Now, in between them, you'll see there are places where there's a lot fewer particles. Yeah, particles are a bit rare, if you like, and they're called rarefactions. So in a longitudinal wave, you've got compressions and you've got rarefactions. Remember that, you need to know it. Now, as the waves travel through the medium, the particles are displaced. Yeah, they're put out of place. If there wasn't a wave there, then all of the particles would be around here somewhere. This is like a water wave, and if there was no wave, then that would be the level of the water there. Okay, so the particles are displaced, and the maximum displacement is called the amplitude. The distance between a point on one wave to the same point on the adjacent wave, the next wave, is called the wavelength. Okay, so here from that crest of that wave to the crest of that wave, that distance is a wavelength. Or you could do from trough to trough, or you could do from any point to the same point on the next wave. So it's actually the distance between points on adjacent waves which move in phase. They go up and down together, and that's the wavelength. The number of waves which pass a point every second is called the frequency. If this wave was going under a bridge and you were stood on the bridge and you counted how many waves went under the bridge every second, that's called the frequency, and that's measured in hertz. And we're going to talk a lot more about wavelength and frequency in the next video.